So it's a day 2 of Statistics Made Easy virtual SPSS conference. So we have done, and today we will do like data entry in SPSS, cleaning of data in SPSS, coding and decoding of variable in SPSS, descriptive analysis in SPSS, including normalcy check of quantitative data or continuous data, how to split file, SPSS file, how to select cases in SPSS, and why the need of these to split and to select cases in SPSS. We will discuss how to save SPSS output sheet in Word file, how to transfer SPSS data back into Excel sheet, and after that, we will discuss today's topic parametric test, including independent t-test, dependent t-test, one-way ANOVA, post hoc analysis for multiple comparisons, and non-parametric test, including Mann-Whitney U test, Wilcoxon signed rank test, Kruskal-Wallis test, including post hoc analysis for multiple comparisons. So before going to parametric and non-parametric, I want to recapitulate yesterday's session. So we have discussed the data or variable, and we know that it's a qualitative or categorical data and then quantitative data. There are two types of data. I have added one more categorical data. Some categories like male or female category, religion is category, color is category, personality is category. So categorical data. So it's a come into qualitative, and quantitative, that is a number. So is there relationship between these level of measurements and data or variable? So we will see as when we talk about the level of measurements, there is a nominal, ordinal, interval, and ratio. So nominal and ordinal level of measurements come under qualitative or categorical variables. So nominal and ordinal come into qualitative or categorical variables. And when we talk about interval or ratio or quantitative relationship with the level of measurement, so what we see that again ordinal and interval and ratio come under quantitative variable. So when we think about that, ordinal come in qualitative category or categorical variables, and also comes into quantitative category, quantitative variables. So what's the difference between this? So when we talk about the ordinal, like I want to give example of disease severity. So disease severity is minor, major, moderate, or severe. So this type of order or ordinal data or variable comes into qualitative or categorical type of data. But when we talk about pain scale, which has 0 to 10 numbers according to no pain to severe pain. So when we talk about NRS, numerical rating scale of pain, so there are numbers. So it is also a ordinal scale, but now this scale comes under quantitative. So we have to think about the data. We have to understand the data. Then we have to put data qualitative and quantitative. Interval and ratio, it's very simple, come into quantitative variables. And this is, yesterday I put a example in WhatsApp group, and I asked some like type of descriptive statistics stats. So there are beautiful conversation between participants and us. And when we talk about the state is a nominal variable. We cannot order the state. If we order the state, what happen we can see. Okay, this state is higher than this, and this state is higher than this. So there are a lot of issues will create if we like order the state variable. So if we cannot order the state variable, it comes into nominal category level of measurement. So for nominal level, we can when we talk about descriptive statistics, so we can do only mode, count, frequency, and percentage. So this is the beauty of level of measurements and type of descriptive statistics. Now I want to draw your kind attention on dependent and independent variables. And I want to give one example, one or two example. So effect of diet modification on weight. Effect of diet modification on weight. We want to get the effect, we want to get the effect of diet modification on weight. So diet modification is independent variable and weight is dependent variable, because weight is dependent on a diet modification. Same as effect of divergent therapy on pain, and you participants, you have to think which is a dependent variable and which is independent variable in number 2 example. So this is a parametric versus non-parametric test. And when we talk about parametric is a powerful test, robust test, and non-parametric are weak test. When we talk about independent or dependent variable in parametric or non-parametric, suppose independent variable is two independent groups, only two independent, not more than two, or categorical variables. And our dependent variable is quantitative. For example, weight. And two independent group is one group diet modification and second group there is no diet modification. And we want to compare the effect of diet modification on weight. So we have to use independent or unpaired t-test if the dependent variable, that is quantitative, follow the normal distribution. So before parametric test or non-parametric test, we have to check normalcy of our dependent variable always. Quantitative dependent variable, continuous dependent variable. And if this quantitative variable, weight variable, doesn't follow normal distribution, then we have to use a non-parametric test, that is a Mann-Whitney U test. At number 2, it is the same group or one group and before and after phenomena. So if in one group, I'll check weight of the group or subjects, then I'll give diet modification. Again, after 6 months, I'll check weight of the, and I want to compare the weight. I want to get the difference of weight before and after, because it's a variable is dependent, that is a weight. So I have to use dependent or paired t-test because there is a pair before and after. If the data, if our dependent variable is follow normal distribution, otherwise I have to use Wilcoxon assigned rank test instead of dependent t-test. And when we have more than two independent groups, for example, one group diet modification, second group exercise, and third group nothing. We don't give anything, no diet modification or not exercise. So, and dependent variable also is weight. And we want to examine or assess the effect of these diet modification or exercise on weight of the subjects. So we have to use one-way ANOVA, one-way analysis of variance. If the weight is follow normal distribution, otherwise we have to use Kruskal-Wallis test. And when if a independent variable and dependent variable both are quantitative like height or weight, we know that weight is depends on height. So we have to use Pearson correlation coefficient if height or weight both follow normal distribution. Otherwise, we have to use Spearman rank correlation coefficient. And next, one group, and we have to take reading of the weight baseline 1 month after diet modification, 3 months, 6 months, and meets repeated measures or multiple follow-up. And our quantitative dependent variable is quantitative, that is a weight. So we have to use a repeated measure ANOVA or a Friedman test. And there are many more conditions, but we will discuss today about these things and next day. So this is a mnemonic for parametric test. I do pray to Rama. I, that is a dependent t-test. D, independent t-test. D, dependent t-test. O, one-way ANOVA. P, that is a Pearson correlation coefficient. And Rama, that is a repeated measures ANOVA. So this is a mnemonic how to remember these. I do pray to Rama. But when we talk about the mnemonic for counterpart of parametric test, so these are, each parametric test has its counterpart. So how to remember? Because it's a weak. Non-parametric tests are weak. So sorry to say, it's a counterpart we can remember, Mawali Kahinka or Sirfira. Mawali Kahinka or Sirfira. It's for who understand Hindi, and who don't understand Hindi, I have given in English. So Mawali Kahinka M. M is a Man-Whitney test. So independent t-test or unpaired t-test, counterpart non-parametric test is Man-Whitney U test. Mawali Va, W Va. So dependent t-test, counterpart is Wilcoxon signed rank test. K, one-way ANOVA. K, Kruskal-Wallis test. S, Pearson correlation coefficient. S, Spearman rank correlation coefficient. And F, that is a Friedman, counterpart of the repeated measure ANOVA. So Mawali Kahinka Sirfira. Again, if you don't understand Hindi, you can like remember in English, Mr. Wilcoxon kindly see fried rice. So you can easily remember this. M, Man-Whitney, Wilcoxon is Wilcoxon, K is Kruskal-Wallis, S is Spearman, and Friedman test. And the condition is single group before and after, 2 groups, 3 groups, repeated measures, and quantitative dependent and independent variables. So before going parametric or non-parametric test, we have to discuss about normalcy check of quantitative data in SPSS. So before this, we have to some knowledge about hypothesis. We will discuss, I will give demo how to check normalcy in SPSS. As we know that hypothesis in normalcy test and in general hypothesis is a statement of relationship between 2 or more variables. And null hypothesis, similar finding or no significant change or difference. And in research or alternate hypothesis, there is a significant difference findings or change. The null hypothesis of normalcy test states that the sample is normally distributed, and we want our sample must be or should be approximately normally distributed. So we don't want to reject null hypothesis. Against the alternative hypothesis that is not normally distributed. So we favor in normalcy test, we favor null hypothesis. In other conditions, we favor alternate hypothesis. We want alternate hypothesis. If the normalcy test, most popular normalcy test is Kolmogorov-Smirnov test or Shapiro-Wilk test. P-value is less than the predefined significance level. That is usually we define p-value is less than 0.05. We have to reject the null hypothesis and conclude the data are not normally distributed. So in Kolmogorov and Smirnov Shapiro-Wilk test, we want a p-value greater than 0.05 because we don't want to reject a null hypothesis. We want our data normally distribute. If the p-value is greater than the predefined significance level, that is a p-value less than or equal to 0.05. We cannot reject the null hypothesis and conclude that the sample is normally distributed. And we want this, not that. And we have to remember this. Don't rely only and only this normalcy test. And reason is not that the small deviation from normality can produce a statistically significant p-value, that is a p-value less than 0.05, when the sample size is large, even greater than 30. So if there is a minute deviation, so normality disturbed, we get p-value significant if sample size even greater than 30. And conversely, it can be impossible to detect non-normality with a small sample size. So we should always examine the normal plot also, like histogram or QQ plot, and use our judgment, researcher judgment, rather than relying solely on the hypothesis testing. So we have to remember this. So when we talk about the histogram or normal distribution, you can see this type of histogram we can get from SPSS, and this is hemoglobin of the patients, and this is the number of the patients. And when we get this histogram, you can see this is bell shaped, and bell shaped curve is a normal distribution, represents a normal distribution. And in bell shaped curve or normal distribution, we know that mean, median, or mode rely on middle of the center of this x-axis. So we have to remember. When we talk about skewness, and when we talk about the histogram of quantitative data or continuous data, so what we see in left side, all the observation, major observation, all the observation is far from this y-axis. And you can see the tail is towards the left side. You can see that tail is towards the left side. It's called left or negative skewed. When we talk about the right side curve, you can see here the lot of the observations, majority of the observation towards the close to the y-axis, and the tail is towards the right side. So it's a right side or positive skewed distribution. And then in between or middle, that is a approximately normal distribution. Now, second, normal probability or QQ plot. And QQ plot, also known as a quantile plot, and shows the distribution of the data, quantitative data, continuous data, not categorical or qualitative data, against the expected normal distribution. For normally distributed data, observations should lie approximately on a straight line. I will show this graph on the next slide. If the data is non-normal, the point form a curve that deviates markedly from a straight line. So possible outliers are point at the end of the lines. So you can see here, this is QQ plot, and the observations of our sample is close to this line. So it's a normally distribution. Even if a Kolmogorov-Smirnov test or Shapiro-Wilk test p-value is less than 0.05, after that we can take this variable is considered normal, approximately normal distribution. And if this like hemoglobin is normally distributed, we can apply parametric test. Now let's have fun with SPSS. So I'll demo on normalcy test, how to check normalcy test. How to check normalcy test. coding and decoding in SPSS, parametric test and non-parametric test. I will try my best to explain in simple way. So okay, I have क्या करना पड़ेगा इसका? I think there is computer something, there is a problem in computer. Okay, ये क्या हो रहा है? Okay. Okay, it's okay. Sorry for interruption. So today we will discuss SPSS normalcy test and other decoding and coding on the site. I have sent the site on WhatsApp group, final data sheet t-test. Okay, so you have to open this, and first we can examine this for any problem if we have. So you can say, okay, it's like first the 6 rules we have to follow. Okay, first row contains variable name. First column, oh, okay, first column we don't have serial number. I think one participant asked how to enter serial number in Excel sheet. Okay, it's very good for him. So what we have to do, because I told you that first column serial number. So I have to click here and then right click and then insert. So this is a column cam. Then I have to write down S underscore number. Then click here 1 and then down arrow 2. Again, I have to click on 1 number, then shift and down arrow I have to press. So there is one marker in box, a small box, and I have to bring my cursor on this. So my cursor color change into black, and I have to press it and drag it down. So there is a serial number automatically come. But this way of serial number doesn't come in SPSS. So it's a beauty of Excel. Now our file is okay. I can say our file is okay. So I can see our file. Okay, because we have to examine first file. And I have separate systolic BP, diastolic BP, sodium and potassium. Very good. And then we perform normalcy test. So normalcy test for continuous variable. And in this Excel sheet, what are the continuous variables? Age, height, systolic BP, weight, diastolic BP, sodium, chloride, and many more. So we will do, okay? So I have to cross it. I have to save. I have to open SPSS. There is icon. I have to open. And then I have to take rest for some time. It will take time. It's opening. Now it's opened. Very good. It's a SPSS sheet, blank. So I have to import Excel sheet in this SPSS sheet. So I have already demo you yesterday one way, first way how to enter And today we will discuss second way. So first way, just click on file, then open, and then data. If you click, this is a first way, just revision, click on data. You can see where is my SPSS file on desktop. I know where is my SPSS Excel file on desktop, in which there is a IMBSS 2020 day-wise schedule. And what I see, there is no Excel file. Why? Because there is a file of type is SPSS. I have selected default selected. So I have to click this button, and then there is a Excel. And as I click on Excel, so the file came here, t-test. And then I have to click open. And I check this, okay, it's a first sheet, okay, no problem. And I have to see these three boxes must be checked. Okay, must be checked. Then I have to click OK. Then it automatically imported in SPSS. But I want to show second way. So I cross here. Then second way, file, import data. This is a second way. And come to here, Excel, and click on this Excel button. And this Excel is automatically comes. Okay, this is Excel. This is, click here and then click open. Tomorrow we will discuss third way, or maybe today, no problem. Okay, these are three checked. Then click OK. Then my file automatically came in SPSS. Now, first I want to save my file because yesterday I did not save. So I want to save my file. So how to save? Just click this button. Okay, just click this button. This is a save, or otherwise click on file and there is a save or save as option. We can save it. So first I want to show this button, click button, like save button. This is a save this document. Just click over there. And this is on IMBSS 2020 day wise schedule folder. This file will be saved in this folder. So I want to give name day 2 t-test. Okay, then click OK, save. So automatically my file save in IMBSS folder. I can see here. Okay, day 2 t-test. Very good. Now, normalcy check. And you know that I want to check normalcy of age data, but there is some mistake in age data. Age is a continuous variable, quantitative variable, continuous variable. But what happened? This is icon is three balloon in different color, and this is A for alphabetic. It's a string variable, means word variable. But I know that it's a quantitative variable, continuous variable. So I have to change it. There are two ways. I can go in variable view, left below. I click here and go and search where is age. And you can see age is here. And in type of variable, you see that it's a string. But I know that it's not a string. It's a numerical variable. So I have to click here. This dialog box comes. And I have to, this is a string select automatically or by error, I don't know. But I have to, because I know that age is a numerical. So I have to click here. And you can see this is a width of that column. Means if you enter because we know that age is only two numbers, because we have selected 18 to 80 years. So age is only like two numbers. Okay, 1, 8, 2, 6, they all are two numbers. So width is 2. If I want to give decimal in any variable, I can write down here 2. But in age, there is no decimal, no need of this decimal. If I want to like increase the width of this, I can click on 4 or 8, whatever I want. Generally, I took like as a 8. Decimal in age, there is no need. But there are some variable I need decimal. For example, height, weight, BMI. So I have to put decimal here. And then click OK. So what happened? Here, you can say that a alphabet has gone. But is also a like nominal. This is a type of nominal level. Nominal. Okay? Measure this. This is a nominal. You can see here. When I put my cursor here, so this is nominal. Measure is nominal. Because I know that it's not a nominal. It's a scale, ratio. Age is a ratio. So again, I have to change. It's a scale measurement or level of measurement. So like same way, I can click this variable view. Otherwise, it's a very simple. If I double click on age, so directly I can go to age in variable view. So double click here. You can get it's a coming age. Very good, because I have to change age. So this is you can see in the right side there is a measures. Measures is in age is nominal. So I have to click here. I have to change. Age is a ordinal. No, age is a scale. So I have to click here. Then if I double click this age, automatically I can go in data view. Otherwise, I can click this button data view. I can go over there. So I want to like have shortcut method. Double click this in age, in front of age. Yes, automatically age came. So it's like a beauty of SPSS also. You can see. And where is my serial number? Okay, I have to have serial number. Then I want to like now I want to check the normalcy of age. So what I have to do, I have to click analyze button, most popular famous button, analyze. Then I have to click this. I have to select this, or I have to put my cursor here, descriptive, and this a small window will come with these. And where is normalcy test? Normalcy test is here in explore. So I have to click here. This dialog box comes explore. And what I want to do, I want to check the distribution of age. It's normal or not normal. I want to check Kruskal-Wallis or Shapiro-Wilk test. Okay, so I have to Kolmogorov-Smirnov or Shapiro-Wilk test. I have to. Sorry. So I have to click this age, and then I have to click this arrow, horizontal arrow towards right side. So age automatically will come in dependent list. Then no need to go in statistics, just go in plots, click here. And normality plots with the test. So I will get normality plot and test also. And I want to show histogram also. There is no need of this stem and leaf, and there is no need of this box plot. So I like click here none. And I have to click normality plot with the test. Always click this. Then you can get result and continue. And I have to remember this display is click here both. I have to select both, not statistics or plot. I have to select both. If I click on statistics, I can get only hypothesis test, Kolmogorov-Smirnov or Shapiro-Wilk result. If I click on plots, I will get only histogram and QQ plot. But I need both, so I have to click here. Then click OK. So this is the output window. This is 60%. There is now you can see that there are missing 81 missing cases. There is 81, but I know that there should be no missing case in a SPSS. So what happened? So in between, it's a very good thing. So I have to go in data sheet and see below, because 60, there is a 60 case. And what happened? You can see these are the dot below 60. Sometimes these dots come. So there is no problem. It's okay. We have to select these dots and we can delete these dots easily. So what I have to do? I have to click here on 61, then shift and down arrow I have to press together, and then you can see here. And up to here 141 the dots are here, 142 there is no dots. Then what you have to do, you have to click here, you have to click here, not here. You have to click here, otherwise you click here and right click, okay, right click, then this disappear. So again I have to first click here, then shift and down arrow, because I have to remember these dots. Sometimes when I calculate frequency or percentage, then it will give wrong results. And then I have to click here. I put my cursor here, not here, and then right click. Then clear, just click on clear. These dots automatically gone. Okay, so now repeat same test, analysis, descriptive statistics, cross explore, and then as we have selected all the things, just click OK. And what you see, we have to wait for there. Where is missing? Missing is 0. 60 cases. Oh, it's very good. And you can see in descriptive there is a mean and a standard error, and 95% confidence interval of mean. Very good. And this is a median also, variance also, and this is a standard deviation. This is minimum, this is maximum. And please never use these range or interquartile range. From here, please never use. Because in range, there is a minimum and maximum, not this. So if you minus the 72 minus 18, so you will get this 54. So in results, you have to write down 18 to 72 years. Not this range is 54. Remember this. And in interquartile range, please don't write down this 21. This is also a range. So you have to first quartile and third quartile. You have to have value. So how to calculate this interquartile range, we will discuss. I think yesterday I have give demo, but okay, no problem. And what happened? This is a test of normality. This is Kolmogorov-Smirnov test, and second is a Shapiro-Wilk test. This is value of this Kolmogorov-Smirnov KS test, also famous as KS test. This is a degree of freedom, and this is a significant SIG, that is a p-value. So remember in SPSS, okay, you will see significant SIG, significant, that is a p-value every time, okay? In every test like parametric or non-parametric, SIG, two-tailed, okay, one-tailed, we have to prefer two-tailed. If there is no tailed, it means it is a two-tailed default. So this is 0.003. It is less than 0.05. So we have to reject null hypothesis, and we have to go with the alternate hypothesis. And when we go with the alternate hypothesis, so it's a sample is variable in our sample is not normally distributed. And again, this is another test. This is a Shapiro-Wilk test. This is a value of Shapiro-Wilk, degree of freedom, and this is a significant p-value. This is also coming less than 0.05. By using this Shapiro-Wilk test also, I have to reject the null hypothesis. Null hypothesis in normality test is a sample is normally distributed. So I have to reject that, and I have to go with the alternate hypothesis. And my alternate hypothesis in test of normality is my sample is, my variable is not normally distributed. So I have to, what I see that age is not normally distributed in my sample. Using this Shapiro-Wilk test, I prefer Shapiro-Wilk test over Kolmogorov-Smirnov test, because with the help of Shapiro-Wilk test, minimum sample size like 5 to maximum sample size of 5,000, it is very good test. But when we like talk about the Kolmogorov-Smirnov test, it's like not good for small sample size. It's only good for large sample size. Okay, and I have a lot of articles related to this. Shapiro-Wilk is more powerful than Kolmogorov-Smirnov test. And what we see, okay, as I told you, don't rely on these statistics. I have to see QQ plot and histogram. So I want to see, okay, this is, and there is no normality curve line. So no problem, we will make normality curve line here, no problem. Then we see what this, and before this, we can go with the QQ plot. You can see this is a straight line here, and all the observations are close. Maximum observations are close to this. Only 1 and 2 outlier, and this is 1 and 2 outlier here. So we have to check the outlier is correct or not. Because if we are like age is not normally distributed, I have to use non-parametric, and that is not robust or a very weak test. Sometimes it is very difficult. The journal accept this our non-parametric test research article. So I have to check these. What is this? So if you think that okay, it is like approximately close to and approximately normal, so there is no need to go with this. And you have to remember this: if sample size is more than 30, so if little bit deviation in normalcy, so Shapiro-Wilk test or Kolmogorov-Smirnov test will come significant. But in our case, sample size is 60. So okay, if because and depends on a researcher judgment. If I am a researcher, I will took age is a normal distribution. But please go with your guide and co-guides, what they want. Okay? Because you know you have to complete your degree with your guide and co-guide, and otherwise you can use median and IQR, no problem. You can use median and IQR and go for non-parametric test. If you go with the parametric test and you assuming that age is a sample size on the basis of histogram and this QQ plot, you have to mention over there on the basis of histogram and QQ plot, you assume this age is a normally distributed. But in Shapiro-Wilk, the p-value is this much. Okay, so you have to explain, and you can go for mean or SD. I want to like draw a curve line here, bell shaped line here. So what I have to do, I have to click analyze descriptive statistics, and then I have to go frequency. I want to check normalcy or histogram of this. So I have to click H, then this is arrow. I have to click, this comes in variable view. Then this is a chart. I can click on this. These are the mean, median, okay, no problem, quartile. This is the standard deviation, minimum, maximum, all the things I have already got in explore. Okay, but I did not get this quartile, so I click here, and you can get is, and also you get like skewness and kurtosis also, we will discuss. So just click OK, and then chart, you have to click chart. So there is a histogram option, and show normal curve on histogram. I need this. I have to click this and then continue. I don't need a frequency table for continuous data. Okay, so I have to declick it, and then okay, click OK. So what I see here, this comes here, you can see here. Okay, it's looking like approximately normal distribution, bell shaped curve. It's looking okay. I can take like edge is a normally distributed. But if I see skewness of this, so what I see, where is a tail? You can see where is a tail of this. If you don't remember this, and if you cannot judge this, where is a tail, is a left side or right side? Okay, so I think this is a tail is in left side here. Okay, because there are like a lot of observation, like majority of the observation is are far from this y-axis, and tail is in the left side, more tail in left side skewed. So it's a left side means left skewed or negative skewed. Okay, just check. So this is here, you can scroll up, and in descriptive statistics you can see skewness, the value of the skewness is minus. It means it's a negative skewed. But for normal distribution, it must be 0. So you can say, okay, it's a close to 0, 0.6. Okay, it's close. I can take this, no problem. And also kurtosis, you have to take 0 for normal distribution, but it's also close to 0. So, okay, I can take this as is a normal distribution, but you have these evidence with you. Okay, now we will go for coding and decoding. And now I want to save this output. So there are two different ways. First, if I want to save this output in SPSS, so you just have to click here, this button, save this output, save this document. You just click here. This output window come, output 1. This is normal C test and C test. Okay? Normal curve test. Okay. And then click save button. So this output save in SPSS file. I want to see, okay, I want to see. So where is SPSS? In document, I have to click document. Oh, where is that? Oh, this is NC test. Oh, here, no problem. In future, I can use it. Very good. But if you want to save this outcome in Word file, then you have to click here, export button. This is a paper and this is a arrow, curve arrow, green arrow. You have to click here. This window will pop up. And please remember, you have to click this all visible, not all. You always all visible. So click here. This is type Word or RTF. Okay, I want this. Then I want to like give name. There's already file normality results. So I want to change this. So just click number 1. You can click here and you can, because I want to save in desktop. So, okay, it's very good. Normal results. So NC test on desktop. And then click on change option here. And please default this wrap table to fit within page margin is selected, default. But please select this shrink width to fit it within page, because we want to within page margin, shrink, okay, within width. So please click here and continue. And now click continue. And then saving the export to a file in Word, I want to check. Okay, where is, okay, this is NC test. Click here. You will get your result in now Word. Very good. I can get printout from anywhere, like wherever I like, I want in photography or any other shop I can get, because they don't have SPSS. So it's very good. All the results come on this Word file. You can see here. Okay. Now it's open. Now I move for second session of the today. Okay, I want to cross it. No need of this cross. Okay, already saved, so no problem. Now I change this age. So I have to click this because this is a save button. Every time I have to say in a day to test, I have to click here and this output window will come. Okay, I need this. So this highlight button, okay, there is a gone, highlight gone, okay. So now I want to give code and decode for gender, and I have, you can see here, group. I want to perform t-test. I want to perform a repeat, like paired t-test, independent t-test, and ANOVA test. Sorry. I want to perform Mann-Whitney test, and I want to perform other Kruskal-Wallis test and Wilcoxon-Sandring test. And I want to see that, and my guide see that this is a case and control, and want the difference of age, because I have taken age is a normal distribution. So normal distribution go for t-test. If I don't take age is a normal distribution, then I have to go for Mawali Kahinka. Okay, you have to remember Mawali Kahinka. So I have to decode it, no problem. So what I have to do, click here, transform. I want to give case is a one number and control is a two number coding. So I have to click here. I have to check spelling of case and control. Okay, there is any problem? Okay, all are the same in capital letters. There is no mistake. Very good. Then I have to click transform. And always click this record into different variable. If you record into same variable, so your coding will come here. 1 and 2 come here, but I don't want this. I want a separate variable, group code, separate variable. So just click here, record into different variable, click here, and group, put it here. Okay, I want to change this group code and decode. Then output variable is a group code, GROUP, group code. Very good. If there is a mistake in spelling, it goes, no problem. Then I have to click change. It automatically comes here, output variable. Now, old and new values I have to click. So value is, old value is case. So I have to write down CASE, case, and new value I want to give 1 and add here. Now control. Then I want to give 2. You can give 0 or 1 also, no problem. And then I have to click 8. Okay, I have given. Then continue. Click continue. And then click OK. So this is output. And I want to see SPSS seeds. So where is my group code variable? Where is? Because it always the last at the end of this seed, because we have created this. This is a group code 11112222. Okay, this is 111222, and these are some other variables. There is no data. I have to select it. Then I have to shift and left arrow. Okay, and I have to click here, click here, and then shift and right arrow, and then right page. I have to click and then clear. Automatically gone. No problem. Then I have to save this. Every time you have to save, otherwise you will lost your data. So click here. Okay, it's saved. So this is a group. Now, if you want to, how many patient is control and case, and I know that I have given code to case to 1 and control to 2, and I remember because I just have given these codes, but after many days I can forget it. So I have coding, I have given the coding, so now I have to decode it. So these decode can come here, and how we will do? Okay, I will give demo. So first of all, as I told you that a group is a case or control is a nominal variable. So I want to do what statistics I have to calculate for it, for nominal, frequency and percentage. Okay, so I have to click here, then descriptive statistics, then frequency is okay. I have done all the things with age, so please come back, respect your variables, click group code. I know where is group code. Otherwise, if you have long data sheet, so I know that I have given group code. So just click here S number and press G. Press G on your keyboard. So G group and then gender and then gent and then group code. So there is no where is my variable. There is no need of this. Only just press here and G group code G. Okay, group code here, very good. I have to click this. Then statistics. Okay, I don't need these things because this is a nominal variable. If we calculate this, it means we are don't know about statistics. Statistics is understand the data, play with data, talk with data, and listen to data. So I have to click display frequency table. Please remember, if variable is nominal or sometimes ordinal, because ordinal is also a qualitative or categorical. So I have to click here and then OK. Then I got okay, very good. And then you can see it's a histogram. Oh, yeah, I don't need this histogram. What? I'm laughing at me because I don't need this histogram, but it's a like a lie. You can see it's a normal distribution. Very good. But it's a qualitative data. It's a nominal data. And if I get histogram for this, so it's a foolish thing, foolish work for me as a statistician, because I did not deselect in when I calculate this frequency or a percentage over there because I have selected already histogram. So please click here and then delete, gone. You can see here 1 and 2, 29. 29 is case and 31 is control. And this is with the percentage. And please remember, every time you believe on this valid percentage, never believe on percentage. Why? Because if you have missing value, the missing value come here with there. How many missing value? Suppose 8. And this percentage distribution is according to this, including this 8. So this is not a valid percentage. So please, to avoid this confusion, always take valid percentage. 29 out of 60, how much? 48.3%, and control. But today I remember that one and case and one, two is control, but after some time I can forget it. No. So I want to decode it. I want to decode. So I remember, there is no need to remember. Okay. So what I have to do, I have to minimize it. I have to go in data sheet, and then there is a variable view. I have to go in variable view. This is, I have to go in variable view, click here. Then I have to search where is my group code. Otherwise, you can directly double click this group code. You directly reach over there. No problem. Oh, group code. Why I need decimal? There is no need of decimal because this is nominal. No need of this. So I can remove it. Oh, very good. Width 8, okay, it's okay. Then I want to give value. I want to give decode. Okay, I want to. So I have to click value, and value number 1 and label as I know. Right now I know that case, and click OK. Value number 2 I have given for control. I remembered. Click 8. Then OK. Now same thing I want to analyze. Analyze descriptive statistics, frequency, and where is my group code? You just click here, G, 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 and G. Okay, very good, sorry. Okay, group code is already here, okay? So there is no problem. And I have to click OK. So now case and control. 1 is replaced by case and 2 is replaced by control. So it's a very good thing. And now these are the valid percentage. We can write down in our manuscript. So this is a code and a decode. Now I want to transfer my this output in Word or SPSS sheet. I can transfer easily. Okay, click here, all visible, and this is, please don't please don't if I click on OK. So there is already a file name with NC test. So please don't do this. We have to, okay, this file is replaced. So there is a lacuning of SPSS. You can see this file, I select no. After that, the file is replaced. I think replaced. I have to check. Yeah, that file is replaced. So this is lacuning of SPSS after deselecting crossing that. I don't want to select like save, but after that, the file is replaced with this. Okay, so I want to cross it. Don't want. And this is SPSS file. I have given this. This is data view. And now I want to check because I have taken like as like age is a normally distributed. So, and there is a group code is there are two groups, two categorical, two groups, and normally distributed. Dependent variable is normally, that is a age. Okay, I want to compare. Although age is not like dependent variable, but we have to consider age is a dependent variable or compare between case and control. So I have to use a t-test. So how to use t-test? I have to click analyze. There is a compare means and there is a independent t-test, a sample test. I have to click this. Then I have to click age and in test variable, I have to click this arrow. Otherwise, no problem. I can drag and drop here age, no problem. And then where is group code? I know I have to press G and I get this group code. And in grouping variable, I have to put this group code, click here, and then define group. And define group, what I have given 1 and 2. Okay, I have already given 1 and 2. So I have case, I have given 1 and control, I have given 2, and this is I have to click continue. Don't use this estimate effect size, there is no need. In 27 version, I think it comes, but there is no need. There is no need of option and bootstrap. Just click OK. So what you see, this is case and 29, control 31. This is a mean and this is SD. Please use only 2 decimals. So 0.78. And why I told like 0.78, you remember, and 0.08. This is the mean and SD. And where is the difference is okay around 10 years in case and control. So this difference is significant or not, I have to see p-value of a independent t-test. And where is a p-value? The p-value is here, significant two-tailed, and this is coming 0.00. This is it's up to 3 decimal. But if you click this p-value here, it's come in 6 number digits. Oh, it's very good, 6 number digit. I need in 6 number, I can take, otherwise I can take in 3. So you have to click and then. And what about this p-value? This is a Leven's test for equality of variance. And you can see there are two p-value, and luckily they both are same. But sometimes both are different. So confusion, which I have to take. So you have to see this p-value significant. This is a Leven's test for equality of variance, and this p-value is 0.275. So remember, if this p-value is greater than 0.05, so we have to consider equal variance assumed, and then we have to take p-value of this. But if this p-value is less than 0.05, then we have to take equal variance not assumed, and we have to take this p-value. It's called Welch test p-value, Welch test. This is a correction in the t-test. It's called Welch test. It's called student test p-value. It's called Welch test p-value because in our data, in our analysis, it's come more than 0.05. So it's we have to take this p-value. So mean or STN, and this is a p-value. Now I want to do paired t-test. So paired t-test means there is data in a before and after. And I know what I did in my study. I took at baseline measurement of these WHO quality of life and also on 3 months follow-up. I gave treatment or surgery. I'm like, there is a surgery. And then after that, there is quality of life. I checked WHO quality of life after 3 months of surgery. So before I have like quality of life and after I have quality of life. So I want to check, but I want to check in cases, not in control, or separately I want to check, because paired t-test always used for within subject and independent t-test is used for between subjects. So for within a subject, what I have to do, and you have to make some corrections because this is a paired t-test. Again, this is a nominal variable. So I have to correct these nominal variables. So I have to click here directly. This is a shortcut method. There is no need to go variable view. Directly correct here. I don't have time. So okay, just click here. And then I have to remember there is a decimal or not. I think there is no decimal. If you give one decimal, it's okay. There is no problem. And I want to like 8. Okay, very good. Numerical change. Okay, numerical. Width 8, decimal 1, no problem. We can give decimal 1 and okay. Then okay. Then width 8. And no need to do width 8. There is okay. It's okay. Only two widths is okay. Okay, no problems. Click here. 8 and 1 and then what I see, just click OK on 49 number. So what I see, okay, very good. I have like a right sided, this is, and these are the for nominal, but it's okay, no problem. We can take, there is no issue. We can take it as a, there is no need to, every time you have to convert it into scale measurement. But if you want to convert, you can convert. This is nominal, you get scale, this is nominal, scale, this is nominal, scale, and this is nominal and scale. Because I know this is a WHO scale is a scale, okay? Ratio. And where is at baseline? This is a baseline. You know, this is a baseline. And I forgot to give name as baseline, but I remember this. So I can give baseline also. So also there is a problem. I have to just click on this. I got. So I have to a string numerical and I do okay. It's okay though there is no problem. Then okay, click here numerical. Okay. Then click here numerical. Okay. There is no only 2 width. It goes no problem. Then I don't want to check this nominal. There is no problem with this. Okay, I have arranged these and I want to change before and after surgery. I want to see change, and before and after, it means there is a use of the paired t-test if the WHO scale is normally distributed. Otherwise, I have to go for Mawali Kahinka. Okay, you have to remember that. But paired t-test or Wilcoxon signed rank test, we have to apply in within subjects, before and after within subjects. So I have to, and here I know that my data sheet has case and control. So I cannot use this test. So I have to split my file. I have to split my file before, and then I have to apply paired t-test. So I have to click here. There is a split file, and then I have to click compare groups or organizing output by groups. It's okay. I have to click here. Then I can go for with the group or group code. So just click here, GGG, and then group code. I have to click here. I have to put this group code because I have to split my file according to case and control. I want the effect of surgery within case and within control. Then I have to click OK. File sort cases by group code. Okay. Now I have to click analyze. Now I can apply paired t-test, compare, and then paired sample t-test. And you can see here only scale on only these nominal which don't have any string here comes here. Other all the like A with A alphabetic gone. They are not visible here. So I did this. And I want to change with domain 1. So I have to click here first and domain 1 to 3 months domain 1. I want to see comparison, change, where is change, mean change. Okay, so I have to click here, put it here, then domain 1 at 3 months, I can take this domain 2 and this after 3 months domain 2. Okay, then just there is no need of this. No need of this effect, estimate effect size. I want to, because I don't have time so much, so I have to want to click, and you can see this is group code, this is case. So these are the within case, what's the difference of surgery. So I can see 28, but there are 29. So it means one is missing or maybe lost to follow up at 3 months. You can, okay, there is a mean and SD, there is a standard deviation. Please don't use this paired correlation. No need of this. Click here and delete. And this is a mean difference of this minus this, you can get 50 minus 72 minus 22. And you can see here, this is p-value, significant to tailed. Pair t-test has only one single p-value. Just click here, double click, you can see, okay, it's a very like 0.0000, then 4 point something like that. So I want, what I have to do, I have to this p-value take 0.0001. It's a highly significant. Okay, it means after surgery, my quality of life domain 1 is increasing significantly in cases. This is my interpretation using this pair t-test. And in like domain 2 also, this is a pre-baseline WHO quality of life domain 2 mean, and this is SD, and this is also mean at 3 months, and this is SD, and this p like mean is increasing, but it is statistically significant. I have to see this p value. Oh, it's a highly significant. Oh, it's an effect of this surgery after 3 months. So I should do this surgery for others also. When I took for controls, so what you see, because this is a dummy table, okay? So I cannot say this, these are the actual data. So also in control, because I have split the like file in case and control. So this is a group code control, and same you can see here. This is a dummy variable. So this is not actual seat. Okay, so you can see, okay, control also there is a increase because this is significantly increase, 51 to 74 or 57 to 78, significantly increase in domain 1 and domain 2. So there is a need of surgery. ऐसे increase हो रहा है. There is no need of surgery. Okay, because without surgery, WHO is quality of life is increasing. So what is the need of this in control also? So okay, then we have to discuss what happened. Then we have to discuss. So this is a paired t-test. Now I want to tell about, if you with me, then I can tell you Mann-Whitney and
sorry to interrupt you.
Yes, sir.
Sir, now the time is 6:52.
Yeah, okay, only just can you give me 5 minutes?
Sir. Sir, there are
Okay.
so many questions, and so we need to give the
Okay,
answers
so
to
no
those
problem, no
questions.
problem. We can discuss Mann-Whitney and these things tomorrow.
Okay.
No problem, sir, no problem. You know? Okay, okay, no. And then I want to save this file, X this output file. Just click this button, then all visible. And now I have to change. This is a t-test file, t-test. Okay, if I want to give today's date, 26/10/2020, then click OK. And I have to change option. Okay, it's shrink, very good. Then click OK. And I can see my file. Where is my file? Where file is here? Very good. I can see after that.